Hello! In this video, let's work with local and global maximums and minimums. On the first graph, we are asked to identify all local maximum values of age and also at values at which age has a local maximum. This sounds super duper confusing, so let me explain what they mean. The local maximum values of age, if this is the function age and age of x, because I can see there's x and y over here, so that's what we call age. This is y equals age of x. That's what's going on here. So they ask you the height for for the question A. Where is the maximum occurs? What kind of height this maximum has? That's what they ask. For the B, they ask you where it actually happens. That is your input. So in this case, x. That's what they're asking here. Let me do input x. That's for this case. In case it's t or whatever, and then it's not x anymore. So maximums, local maximums, as you already know, those are the local little hills of the mountain. So imagine this function is a mountain, and you're climbing, hiking up, and then you get into first little peak of the mountain, and you're super happy and proud of yourself and doing selfies. Then you keep hiking down. This is a local minimum, by the way. Then you keep hiking up, and then you get one more hill. So that's one more local maximum. That's exactly the idea of local maximum and minimum, local extreme values. For the question A, they ask you what are those local maximums, and the answer is the first hill happens at 3. So I will say age. So the height of the first hill is 3. And then for the second hill, the height is 4. So they ask me how high those two hills are. For the question B, they ask me at which values, those are inputs. Which inputs gave me those outputs, those heights? That is the location of, let me put it in a different color, green, the location of those mountains, the peak of the mountains. The first location is -3, so the first hill is located at -3, and the second hill located at 2. So basically those are two couples of points. The first local maximum, is located at -3 and 3. That's the first hill over here. And the second hill is located at 2 and 4. That's the second hill over here. Not too bad. Now, for the second question, they ask to talk about global maximum. They ask about absolute maximum and minimum. Absolute is the same as global. So that's, if you see both type of terminologies, that means the same thing. Absolute is the tallest. Absolute maximum is the tallest peak from all the peaks, and the absolute minimum is the smallest peak from all the peaks. That's the idea. So I see one peak over here and another peak over here. Which one do you think is taller? The first one is taller. Well, how tall it is. So again, they ask you what is the absolute maximum, not where is it located. Well, it is 3 units high. So I will say 3 over here. Makes sense? Let's do this for age as well. For age, for the second function on the right, I see one hill over here and then one hill over here. Even though it's a little bit cut off, still counts as hill. So I was still hiking, and then say there was a wall here, but I reached it. I reached the hill. So they ask me what is the absolute maximum for age. Same idea. What's the tallest hill here? 3. The height of this hill is 3. So again, it's height over here. Then same with minimums. With minimums, I put it in green color. Check all the pits. That's a pit over here. There's a pit over here. There's no pit over here because this is keeping decreasing forever. And there's one more here and one more here. What is the deepest pit for the graph on the left? So I'm looking at this guy. Wow, that's one super deep. But this function in blue is actually keep decreasing. There's no pit. It's this little arrow means it's keep going down. You just don't see it. And that's why it will be still lower than this pit on the right. That's why I will say there is no absolute minimum for the function on the left, because it's keep decaying forever. I will even draw it finally like this, forever. Like, how much do you want me to go to show you that it is going forever, forever, forever? Make sense? So that's why there is no absolute minimum. There are local minimums, of course, like those two pits I just mentioned, but not the absolute one. Then on the right, as I can see, on the right, I do see pits. Here they are. Now I just compare which one is deeper pit. So the second pit seems to be deeper. I will check how deep it is. It is -4 deep. So it's still height, just for you to understand. It's still height. But in this case, now it's kind of depth, how deep the pit is. What is the deepest pit from all the pits? That's for the global minimum, that's the absolute minimum. And what is the tallest peak of the mountain from all the peaks? That's for the absolute maximum. And that's how you work for these problems. Just make sure you don't mess up with the case number 1, where this little error not supposed to, you're not supposed to just ignore this little error over here. That means the functions keep going, the graph of the functions keep going down forever. And that's why there's no absolute minimum for the graph of the function, for the function g on the left hand side. Okay, good job for watching, and see you in my next video.